So we're getting close to the end of Chapter 4 of Young and Freedman's University Physics, and Section 5 of that chapter is on Newton's third law. If you want to remember, Newton's first law was a body in motion wants to stay in motion and a body at rest wants to stay at rest. Newton's second law is that force equals mass times acceleration, F equals ma, other ways to formulate that. Newton's third law is basically that for every action there is an equal and opposite reaction. Now, this is a difficult concept for me in some circumstances. There are some examples where it makes sense to me. There are other examples where it doesn't, but experimentally this has been demonstrated, so let's move on and do with it what we will. So here's Young and Freedman's technical definition on page 123. If a body A exerts a force on body B, an action, then body B exerts a force on body A, reaction. These two forces have the same magnitude but are opposite in direction. A key point is that these two forces act on different bodies, not on the same body. More on that in a second. Okay, so basically forces always come in pairs. For example, when your weight exerts a force on the ground exerts a force back up on you. We often call this the normal force. It doesn't make sense in a way. You know, I understand that my weight is putting a force on the ground. The idea that the ground is equally and oppositely giving a force on me is a difficult concept for me personally to get my head around, but it makes sense in the sense that I don't fall through the floor, that there is an equilibrium between my feet on the floor and the floor on my feet. They use the example of atoms touching atoms, that there's a spring-like quality in the atoms on the floor that, as it were, pushes back up. I don't understand it all. I just memorize. Ours is not to question why. Ours is just to memorize or fail the test or die. Okay, so here's an example of it that makes sense, I think, to everybody. So if you have two astronauts who are in space and they're completely at rest, and if one of them pushes on the other, then there is going to be an equal force on each of them. Now, they may have different masses, and so their acceleration is going to be different because if they have different masses. But if the two astronauts have exactly the same mass, then if one of them pushes on the other, then they're going to move away at the same acceleration. That makes sense. Another example is, I think this section ends with the example of a mosquito hitting a truck. The mosquito exerts a mass times acceleration on the truck, and the truck exerts a mass times acceleration on the mosquito. But because the mass of the truck is so much greater, the mosquito goes splat. The truck really doesn't feel the acceleration of the mosquito because it has such a small mass in comparison. But F equals ma equals F equals ma, I suppose you would say. Okay, well, how does movement happen? This is the paradox, isn't it? How do we move if for every action there is an equal and opposite reaction? This is where Newton's third law, begins to make us question. But the key is to realize that Newton's second law, F equals ma. So as I sneeze, the force on my head has a bigger mass than whatever I just sneezed, and so my head didn't move nearly as much as what I sneezed did. But for every action, there's an equal and opposite reaction. By the way, this is the way rocket propulsion works, that as the exhaust from the rocket accelerates, there's an equal and opposite reaction for the rocket as it goes up. I mean, this works. There are parts of it that don't make sense to me, but it works. That's how rockets fly. The speed, mass times acceleration of the exhaust is going to equal the mass times acceleration of the rocket. So the key is to realize that Newton's second law has to do with movement. It has to do with the net force on an individual body, whereas Newton's third law has to do with the forces of two bodies on each other, not the net forces on one body. So F equals ma has to do with the net forces on one body. The third law, equal and opposite reaction, has to do with the force of two two things on each other. Well, I don't know if that made it clear, but I think I understand at least what I've said. And there you have it, Newton's third law.